Welcome back to the channel, guys. So today we'll be focusing on your industrial electronics N6. This is the paper that was written April 2025. So today we'll be focusing on your question 8. So let's just check it out, your question 8. Here's your question 8, guys. Let me just indicate it. So the topic that we'll be focusing on is your Thyristor devices and SCR speed control, as you can see here. So now the first question, that was your 8.1. Name three ways in which electrical braking can be achieved. So let's go and write it down, guys. These are the questions you must make sure you know your theory and you just collect all the marks. It's easy question. So the first method is by plugging, right? First method is by plugging. And then the second method is regenerative braking. So it's regenerative braking, right? And then you see is your dynamic braking. Dynamic. Okay, made a mistake. It's your dynamic braking. Right, so those are your three, guys, methods. Now let's focus on the next question. That is your 8.2. Draw a fully labeled diagram of a rectifier circuit employing a commutating diode. So here they want us to. So before, guys, I go to the next question, let's go back to 8.1. So let's say if you want to know more about this three types of braking, you can just screenshot this slide. Let me show you this slide. So here it's about this electrical braking in detail, whereby we are told what really happens when we are dealing with plugging. Armature connections to the supply are reversed via the resistor. This braking technique is normally used in transient application and high-speed drivers. Then you have regenerative braking. This applies to devices where there is a need to preserve energy, like your better operated vehicles. So vehicle supply is removed, which turns the motor into a generator and returns energy to DC source, right? Then you have your dynamic braking. This is used where rapid slowdown is required and regenerative braking is not possible. When the stop button is activated, a conductor places a fixed resistor across the armature while at the same time disconnecting the armature supply. So yeah, guys, that's that. So now let's go to our 8.2. Where is our 8.2? Right. So now, so that you will see properly, guys. So our 8.2, which is 5 marks, says draw a fully labeled diagram of a rectifier circuit employing a commutative diode. So just to go to the slides, whereby we are talking about commutative diodes. So this is basically the circuits they are referring to. So I'll just draw it, guys. Okay, that's our 8.2. I'll just draw that circuit. So you first have your AC supply, right? And then from here you draw your, this is your bridge rectifier, guys. So yes, this is your bridge rectifier. Now, now you have your connect to AC supply, and then after that, guys, you'll just focus on the rest of the circuits. So the circuit goes like this. You have a diode here, and then you have obviously your load resistor, right? So that's your circuit, guys. I always advise writing the topic of the circuit. So this is your commutating diode circuit. Okay, let me just write the correct spelling there. And this is your R circuit. Yeah. So now let's just label the rest that we didn't. Okay, we already labeled that. So AC supply. Here it's a bridge rectifier. This is your bridge rectifier. And then here you have your commutative diode. Just right here. This is M. Okay. Commutating diode. Right? But we can also represent it as a D since it's a diode. Then here you have your R load. So yeah, guys, that's your 5 marks. That's your 5 marks, guys. 3, 4. So it's 4 marks for the labels, and then 1 mark for drawing, for sketching the circuit. So that's also 5 marks, right? And let me just also indicate the mark allocation here. Here you're going to get 3 marks. So now in total we have like 8 marks, right? So let's go to the next question. The next question says it's your 8.3, right? It says define the term DC chopper. Okay, so let's go and define it. Define the term DC chopper, which is 2 marks. Right. Now a DC chopper is the ability of a circuit to chop the battery voltage on and off, on and off to the load. So that's your definition, guys. So the ability of a circuit to chop the battery voltage on and off to the load. So it turns it on and off. Right. So let me just indicate the mark allocation. That was 2 marks. So in total for this question, question 8, you're going to get 10 marks. Right. So guys, if you want us to do other questions relating to the subject or to this topic rather, and there's something you don't understand, just write on the comment section and we'll make an effort to answer your questions. Right. So don't forget to subscribe, guys. Your subscription will be highly appreciated. Help the channel to grow and spread the fire. Tell other people about the channel, Mr. Shortway channel, so that we help one another to become an educated society. I thank you.